All right, folks, now we're going to talk about ratio, rates, and proportions. This is in chapter 5.4 of your book. So quickly, just a note about ratios. So ratios are basically comparing two quantities with the same units. Like here we have 3 circles and 5 squares. So the ratio between them is 3 to 5, and the units are basically how many there are. So there's no real big units here except numbers. We'll look at some examples as well where we'll see more of the same unit and different units. When we have different units, we call them rates. But we'll get to that in a minute. Again, there's a few ways to write ratios. Here are the 3 most common. So you'll see this 3:5, or the word 2, 3/5, or you can see it written like a fraction, 3/5. And I do want to make a quick note that it is not a fraction. Fractions are, you can think of them as a specific type of ratio, where it's always comparing a part, how many you have, to the whole, how many make up one unit. Whereas ratios can be a lot different. They can be one part in comparison with another part. They are, in general, comparisons of two quantities, and those quantities can be whatever you want. But nicely, ratios behave near identically to fractions, so our fraction notation makes a lot of sense for them. Another concept I want to go over with ratios is the idea of equivalent ratios, which is very similar to equivalent fractions. So here we have circles and squares that we're comparing, and we have 6 to 3. But, as you can see, the ratio can be simplified here. Let me kind of show you what's going on. Well, if we look at our parts instead of as 6 to 3, we can group them in equal parts that look like this. So in each part, or each group, we have 2 circles for 1 square. So we kind of triple of 2 circles per 1 square here. And that's the same thing as, well, dividing top and bottom by 3. So this ratio is equivalent to 6 divided by 3 is 2, and 3 divided by 3 is 1. So for every 2 circles, I have 1 square. So my ratio is 2 to 1. Or if you want, you can write it as 2:1, whatever you like. And it works the other way as well. So if I have a ratio of, let's do this, 3 to 2, well, if I wanted to, I could multiply top and bottom. Let me use a different color here, actually, just to make it a little neater. Let's use blue. I can multiply top and bottom by any number I like, as long as it's not 0, to get the ratio of 6 to 4. So that means I double my quantities here. Here's my second quantity. So now I have 6 circles for every 4 squares. So that's the idea of equivalent ratios. All right, so I quickly want to talk about rates. Rates are a lot like ratios, except now we have different units and the quantities we're comparing. So here we're comparing kilometers and hours. So it's a unit of distance and a unit of time. Since they're different units, we're going to call it a rate. And so the idea of equivalent rates are the same as equivalent ratios. So we have this, just a small problem here. So we traveled 300 kilometers in 5 hours. What is our speed in kilometers per 1 hour. So let's go ahead. We have our rate, 300 kilometers over 5 hours. And what they want to do, they want us to come up with an equivalent rate per 1 hour. So I can divide top and bottom by 5. And I get, well, 300 divided by 5 is 60 kilometers. And 5 divided by 5 is 1 hour. So my speed is 60 kilometers per hour. And just a quick note. Any rate that you see where the denominator is just one of a unit, this is called a unit rate. And unit rates are important because it's an easy way of comparing your top number to your bottom number. So that 1 there, that means a unit rate. So when you're asked to find a unit rate, you want to find an equivalent rate where the denominator has 1 unit, whatever that unit is. All right, I quickly want to talk about proportions. Proportion is just a fancy word for rates or ratios that are equivalent. So what we can do is we can set them up as an equation. So we want to find x here so that this ratio, 3 over 5, is equivalent to this one, x, whatever x is, over 35. So what we can do is we can cross multiply. So I'm going to multiply 5 times x and 3 times 35. So 3 times 35, you can check, is 105, and 5 times x is 5x. Divide top and bottom by 5. And we get that 105 divided by 5 is 21. So x is 21. So the ratio 3/5 is equivalent to 21 over 35. So what does that mean? That means that 3 over 5 is in proportion to 21 over 35. And a quick note about cross multiplication. I don't want to talk about this too long, but it's kind of a shortcut. Let me show you what I mean. I mean the following. So what we're really doing when we cross multiply, let's do the same problem. We're really getting equivalent ratios that have the same bottom number. So what I'm going to do is the following. I'm going to multiply our first rate, or ratio, by 35 on the top and bottom. And the second ratio, I'm going to multiply by 5, just the opposite denominator. Just like with equivalent fractions, it will give us the same denominator or bottom number. So then we have, well, 3 times 35 is 105. 5 times 35, I don't know what that is. I'm just going to write that down. It doesn't really matter. Let me show you why. X times 5 is just x times 5, or 5 times x. And down the bottom we have this 5 times 35. Note, these are the same, so it must mean in order for these ratios to be in proportion, these must be equal. So in order for that to happen, in order for those to be equal, this equation has to hold. 105 equals 5x. And you can kind of see it's the same thing as cross multiplying like we did up there. So really, when you cross multiply, all you're doing is you're getting a common bottom number, you can think of it like a denominator, and equating numerators. So really that's all you're doing with cross multiplication. All right, let's do an example. So this is a question I get asked quite a bit by students, is after the first or second midterm, I get asked, well, what do I need on the final exam in order to get a certain mark? So this is the grading scheme for this course. Assignments are worth 10 overall. Your better midterm, we'll call that midterm 1, is worth 25 points. Your other midterm, the one you didn't do as well on, is worth 20 points. And your final exam is worth 45 points for a total of 100 points. And you can look at that as the following bar. So we have this bar of length 100, so that's kind of our whole, and it's broken into 4 chunks. The assignment chunk, let me just mark these in, the assignment chunk, the midterm 1 chunk, the midterm 2 chunk, and the final exam chunk. Okay. So let's look at the following. So we have this fictitious student. The fictitious student got 70% overall on the assignments, which are worth 10 points, 80% on their better midterm, 50% on the other midterm, and they don't know what they have on the final exam because they didn't write it yet. And let's say their target grade, just to pick a grade, is a 70%. What do they need on the final to obtain a 70%? Well, let's use the idea of rates to help us out here. Proportions and rates can help us with this problem quite a bit. A quick reminder that percentage I'll do it in black, so percentage is just, that means out of 100. So that's all it is saying how many parts out of 100. So using the idea of proportion, we want to see how many points the student got in each of these 3 sections. We know how many they need overall, or we can calculate that quite easily from this information here. And we'll have to figure out how much they need on the final exam. Okay, let's go ahead. So let's use the idea of proportions here. So we know they got a 70%, so this is the assignment bit. So 7 over 100 equals so many points out of 10. We'll call it x. And you can cross multiply here, but I can just see almost immediately that if I divide top and bottom here by 10, I get 7 over 10 equals x over 10. Hey, look, they have the same bottom number, so that tells me that 7 equals x. So I know the number of points they got out of 10 here is 7. Okay, so let's look at the next part. We know they have 80% of all of the total marks in midterm 1. What is that out of 25? So again, let's use our idea of proportion. So this is midterm 1. So they got 80%, which is 80 out of 100. And we need to know how many points they got out of 25. Again, you can cross multiply and solve that equation, but I notice I can just divide top and bottom of my first ratio by 4 to come up with the equivalent ratio of 20 over 25. So we get that 20 over 25 equals x over 25. 80 divided by 4 is 20. 100 divided by 4 is 25. I noticed that if I divided by 4, I got the other denominator. That's why I did that. So this tells me that 20 equals x. So I know that they got 20 points out of the 25 in midterm 1. Let's see midterm 2, same idea. So they got, in this case, they got 50 out of 100 is the same as x over 20. Again, divide top and bottom, in this case, by 5. But if you didn't see that, cross multiply, solve that equation, you'll end up with the same answer. And I'll just skip a couple of steps here because I think it's pretty obvious that x equals 10. 10 over 20 is the same thing as 50 over 100. So they got 10 points in midterm 2. So we're almost there. So we want to see what their mark needs to be in percentage on the final exam. So let's work out how many points they need in order to get that final mark of 70%. So they need 70 points overall. So this is the final, their total. So they need 70 out of 100. So now we're interested in the whole. So how many parts of the whole do we have already? We have 7 plus 20 plus 10 is 27. So we have 10 plus 20 plus 7. And this is our unknown. Let's give this a letter. How about x? So plus x over 100. So this tells us that 70 equals, well, 37 plus x. This is good. Okay, so now let's subtract 37 from both sides. So that gives us 33 equals x. So we know they need 33 points out of 45. But what is that in a percentage? So we're going to have to do the reverse here. So here's our exam. So now we don't know how many points out of 100 or the percentage, but we know it's 33 out of 45 that they need. So what is the percentage there? Here, I can't see anything nice to multiply or divide one fraction by to get the other, so I'm just going to cross multiply. So 45 times x is 45x, and 33 times 100 is 3,300. Let's divide both sides by 45. Unfortunately for us, it's not going to go evenly, but that's okay. So the next thing we're going to do is just divide by 45, which I just said. So we get that x. Oh, let me change color here. So x is, and you can check this if you like, it's 73.333 repeating forever. So we'll say x in this case is 73.3%. So in order for the student to get a 70 in the course, in this case, they would need a 73.3% on the final, so 33 out of 45 points.